Good morning, good afternoon, good evening, everyone, from wherever you are joining. And on the behalf of AstroCapsule, I, Prasad Toki, your host, welcome you all to this two-day webinar on space architecture by Elif Keve. So first of all, let me introduce you to Elif Keve. Elif Keve is an architect, designer at Earth Architects, space architect and designer at Think Orbital, and also she is founder of OSA, that is Outer Space Architects and Homeless Architect. She is a master degree student and a volunteer at many STEM-related organizations such as AIAA, S4 Show, SIDI, etc. According to her, she has a natural passion for improving her abilities in space architectural design and specializing in this field to prepare projects in orbitary and on Moon, Mars, and beyond to be one of the architects who lay the foundation of space immigration. On this, Alif, I would like to ask a question on behalf of everyone here. How did you personally get into space architecture?
Okay. I actually I had like natural passion to this space and aerospace. Initial of the space architecture, I was studying um, for the pilot exams of Turkish Airlines. It got me a lot of times for being a pilot, and after that, I actually after like not being successful at these exams, and I succeeded at some levels but couldn't pass some levels because of some restrictions, which I don't want to mention here. I wanted to combine my real major, it is architecture, to the space, and I thought how to do that. I had intention to the master degree, like PhD after that, but I was thinking what title should be. So I met space architecture. That's my passion, the space, that combine it with my major of architecture. And it also, I use my all the knowledge I learned from the engines and aerospace and the flight and everything that made me really happy to meet this title and still continuing on that. Yeah.
Okay, that was great. So, before handing over to you, I just want to give some instruction to the participants. So all of you can ask your questions through chat box. If whatever you want to tell or ask, you can just type it in chat box and we'll convey it to the speaker. If you want, you guys can start your cameras and your microphones are disabled as it may cause disturbance sometimes. Yeah, that's it for now. Elif will start presenting, and after the presentation, we'll be taking a question and answer session wherein you can clear all your doubts. Yes, Elif, the stage is yours.
Okay, thank you so much. I'm going to share the screen. Okay. I think it is, you see the screen. Cool.
Yeah, I can see the screen.
Okay, great. We are going to talk about space architecture today. We have like partnership with the Outer Space Architects, the Turkish-based team that included actually international students as well. We have one of the Indian space architect enthusiast friend as well with us. Uh, I took a lot their support on preparing this presentation for this program. It's over 100 slides that we can make it half today and half tomorrow. And what I will talk about on this presentation is a general introduction of space architecture. I am going to start from the beginning for people who are not familiar with this title. So it's a chance for them to understand from the beginning. And for today, it can be about the general space architecture, and also we will talk about how possible we can settle to the moon and then the Mars. I will take part of the moon for today, and tomorrow we'll continue with the Mars, and then some architectural designs and projects, the technologies as well. It's for tomorrow. Coming up to the introduction of the space architecture. What is architecture? Space architecture. Space architecture is the theory and practice of designing and building inhabited environments in outer space, responding to the deep human drive to explore and occupy new places. We have a lot of reasons why we are exploring and moving, actually. I have titled some of them, but I want to actually ask to students, why do we need space exploration and why do we need space architects? If someone knows something, can just open the voice and talk or can text to the chat box. I'm giving some seconds for students to think about it. If there is no answer, we can keep going.
Okay, there's answer. We are planning to live in there,
Yes.
and we'll need to leave this planet one day. This Aniket. Guys, please put your questions put your answer in the chat box itself. Will not be unmuting it for right now. Okay. Here's Amin. Okay, no. Okay, Ruchira says exploring space will help us better understand our origin on Earth.
Well, that's great answer. Is there another answer?
Yeah, there's Ashleen telling space architecture is needed so as we look at human comfort to not just living it on engineers.
Yes.
Then we have Vishal saying the resources on Earth are limited. We have a large resource pool if we are able to achieve space exploration. We have Bharat telling technology development. We have Amritesh telling space exploration lets us to see the past and beginning of our universe. We have Kaushik uh, saying again to live in there. Yeah, that's it. I answer Rajpal sir with it's a dream of Elon Musk.
Yeah. These all great answers, actually. I also mentioned this with some titles. Yeah, actually, like initially, with the curiosity of humankind to see further, and also with trade makers, we made they make like space tourism with space hotel designs and how make people, the ordinary people, to see the Earth from the space. I believe that this experience will teach all the humankind about the value of the Earth. When we see the Earth from the outside of the outer space, like from the outside atmosphere, as far as we go, we understand that how small it is and how small we are and how weird and silly our problems with each other. We do wars and we do break each other, but all is meaningless when we look at the Earth from the outer space. And I believe that this space tourism will a little support this philosophy of each human who can get the chance to go to outer space to watch. And human species wanted to go to further because they have curiosity to learn differences, to learn and develop technology, because all the technologies as well is developed from the space industry and use it on the Earth. You can check on a lot of technologies which is used in the medical at the hospitals are coming from the space industry's research and technologies development. For me, in these titles, the most important in my mind is curiosity, because human cannot stop their wondering part and wanted to see further and understand more and understand the origin of human, where it come from, where it goes, as one of the students told us in the chat box. Space architecture, the architecture organized and integrated creation and enrichment of the built environments. Designing for space requires specialized knowledge of orbital mechanics, propulsion, weightlessness, hard vacuum, psychology of hermetic environments, and other topics. If you really want to be a space architect, you have to be open to other titles to learn, because it's very disciplinary in the space architecture. You cannot be just a designer. you should be someone who understand about the deep of space, who understand the new things that will occur when you move to further, because uh, everything will be completely different than the Earth. The gravity we learn here, the condition we have learned here, but the extremely differences will face our all the project design. That's why we have to be the best researcher in every other titles such as psychology and physics and the space science law and etc. However, for space architects, when they included to the space sector, it was the importance was the space humans psychology, the human factor in the space immigration. Uh, as you know that there are a lot of short missions has done until now, but after deciding to go to the moon, to the Mars, as you know that it takes like 6-7 months to go and at least 2 years that will be possible to come back. And with this long duration mission, human psychology will not be able to resist to these difficulties, to pass through a lot of radiation and to be to live in a small capsule and with same people all the time. In this consideration, space architects as the artists plus engineers, uh, they they come to into this sector to design, to put the art, to help the psychology of human. Think of a human who lives in an ISS. As you know that ISS has a lot of cables around, so that is kind of whatever you do is still kind of mass, and that make human uncomfortable. With the touch of the architects to the space, it makes the places multi-use, larger areas, and more fancy to see. And they think about sustainability, multi-use of the furnitures as well, so that make help human to have better and larger spaces. I want to talk about actually the first time how space architecture title come up and who is the first space architect. It is start with the Soviet Union projects and in the early 60s, when actually they decided human to leave outer space for a long duration missions. They decided to involve architects to space sector to make better places for the long duration missions. And the first space architect is Galena Balashova, and she is Moscow graduate from Moscow Architecture Institute, and she worked a lot on the zero gravity environment, and she contributed to the interior design of a Soyuz spacecraft that as you see on the picture, and also she contributed Soyuz and Mir space stations as well. And for the second contribution of the space architecture start, it's Skylab Project of USA, and Skylab started in late 60s and early 70s. And it is a space laboratory, and they decided to make biggest area for work and live in this place to make better research in this laboratory. And also architects contributed this project with their research and their decision of the interior color and usage. It's been designed. We have different branches of space architecture as well. If we have like a land of, or if we don't have any land to design. If we have a land to design, like it can be land of the moon, Mars, any other possible livable area. or asteroid surface. In any other designs on these lands included of the planetary architecture, but if there is no land, it's included any place of the outer space is orbital architecture, we say. In the orbital architecture, we have different Earth orbits. As you know that the low Earth orbit is the closest place to move and come. In the recent dates, people moving to the low Earth orbit and coming back very easily, like some minutes. They count themselves among the astronauts as well. After low Earth orbit, there is mid-Earth orbits and also geostationary orbit. Geostationary orbit is a very important orbit actually. It's because it has different specialty than the other orbits. It is usually considered for the space elevators, and because if we have possibility to design space elevators, we have to fix the last point to the geostationary orbit, because this orbit is moving with the same speed of the Earth. So after that, there is high Earth orbit and lastly Lagrange points, and recently some missions has done for these points. In Lagrange points, there are G1, L1, L2, L3, and L4, L5 points, which is fixed too. For the design consideration, I will talk about some important points which we have to consider for our design. And hardship of the being able to reach the destination. It can be Moon or Mars or any arbitrary place. We have to consider how we can reach to this destination. It will take us consideration of the transportation. And the other problems that we face is autonomy, isolation and confinement, lack of external stimuli, and social monotony, lack of resources, hardship of the evacuation in case of emergency. Some of these titles will be fine for the moon missions, but not for the Mars. Such as in the emergency situation, it will not be very possible to move from the Mars back to the Earth, but can be possible for the moon or to any closest orbit of the Earth. However, in these two, whereas for the moon missions, it can take only 3-4 days to move, so that will not affect human psychology than the Mars, as it takes longer duration. So in this case, isolation and social monotony effects. As we said that some of them affects to the moon and mostly affects to the Mars missions. With the human and environment interaction, environmental psychology, it takes time for human to adapt. So the new environment will affect human psychology. Human factor, as we said, that is the most important part, one of the most important part that block the way to move to further. So that's why we have to consider more about the habitability, possible living in the best way. We have 4 titles that we can divide. Human in a space has the survival part. So we can protect human with a shelter, with a covering that is some ISS in the Earth, closest Earth orbits, ISS and Skylabs and other International Space Stations. And as you see here, protecting human from the outer hazards and radiations. And also inside there should be better space for performance, for working as it's needed in the Skylabs, for better places to work in the area, and habitation space in it. We have to think of how to make actually multi-use of all the furnitures and the materials, as we have very tight, very small area to place every need of human. And in this place, as we see that people are trying to act as they do on the earth. They sing, they watch, they make parties and eating way habits. They try to continue their normal life in there. So we have, as I said, that we have to design in the sustainable anti-multi-use way to make better places and open spaces for human to do their own actions. Adaptation is in the two way we can think. Can we change the Mars to the Earth? Can we make it? It is very long duration, perhaps will not very possible for the near time. So we actually first step, we try to not to make Mars like Earth, but make human to be able to adapt to the Mars if we want to move to the Mars in near future. That's why we have to consider how to protect human. That is the title of the architects to think on. There are problems that we face. It is some of them are human factors and some of them are environmental factors. And we can divide them in the psychological issues and reachable points, how to reach to the destination, and the condition of the environment, how that affects to the design and human. First of all, the possibility to transfer. We have to know the distance and how to move in the better way. That is considered in the transportation title. And then to research about the destination land, or how is the gravity and atmosphere, radiation situation, and if they have if it has like meteorites crashes or not, how it takes lights on it, or it is enough or not, and how is the temperature of the place, etc. For the human factor, we have to consider if it's possible to really survive for the long mission, and what to do for live in the long missions. And as human psychology is the most serious factor, social isolation and physical confinement, lack of privacy, feeling of the crowdedness, as even if they are a small number of people can move, but still with the small area that will make a feeling of the crowdedness, and a limitation of independency, as we cannot move every place, and that you have to take your like suit, the clothes of that protect you outside, that always make you blocked of the free movement. Just think of what we did actually in the pandemic of the corona. We get difficulty to use our masks when we go outside. We felt of the hot air that we cannot cover it, and blah blah. We made a lot of discussions with the government, but we never thought that how we would do on the moon and Mars, always wearing all the masks to the body, like all the clothes on the body, and without that we cannot survive outside. And dependency to artificial environment and continuous perception of the risk under simulation over simulations. There are different types of users who will move to this area as they are passed from the different backgrounds, different nations, and life experiences, how they will adapt to each other to live to each other. And the number of the people who will move and how make them to adapt to each other. And also duration of the stay and activities and during the stay will be programmed for each mission. When we combine these two environmental and human factors, we can come up with some solutions. And I can give some example. For instance, from the condition of environment, we can solve these problems with some life support systems, emergencies, and also I can talk about like robotics and technologies we use for protect human from the environmental hazards. And also psychological effects part, we can say that human like how we survive on the earth, we need better lights, we need to better spaces, larger spaces. So in the design concept, always think of how make the area larger with multi-use of the things. As designing on the windows, we have limitation because of the direction of the sun on the if you think of the moon or Mars, it will be different extremely. So how to protect when we do it, how to protect from the radiation as well. In the design process, we also take benefit from the Earth itself. We have to make simulations on the Earth, which is very close condition to the Moon or Mars. One of them is Antarctica, and next is like as you see on the pictures. For this making simulations, we are using deep water for making astronauts to experience of the pressure, high pressure of the water on them. It will be same experience in the outer space missions. And also there are a lot of analog missions. These are teaching human how to adapt. These are all actually teach us how to adapt, living in the cold places and living in the hot places, living under high pressure, and practice how to live with the less amount of food and water and etc. And in the way of to the further to the Mars, we have a lot of levels in technology, what we can use, what to develop. In habitation system research, there are different technologies, and after that these are needed to be tested in the real. So also in the technology we can use for the habitats are also needed to be tested on the Earth in the places that I told on the previous pictures. It can be Antarctica as the coldest place, or there is also high seas area is the one of the place very close to the a view of the Mars and also the condition of the Mars in the temperature as well. In the space industry, there are some spin and spin off system, and that we can take something in the space industry to the Earth and take something from the Earth to the space industry. One of it is from the space industry we can take benefits of pushing space solution into the market. As I said that a lot of technologies of medical part in using in the hospitals and life, we have taken the benefits from the space industry's technology, space research, and providing request technologies and now how to industry as well. This knowledge helped us for also living on the Earth, even if we cannot move to the further, as long as we try. But we take a lot of benefits of it, as seen on the spin and spin off system. And also on the Earth to the space industry, we can consider about spin-in services and collecting technologies demands on Earth to use on the space industry to have more possibility on our plans on the to the further. And so all in all, we can say that as a human cannot yet adapt to the Mars, we can think of how to protect. And in these all the titles we face it until now, we can firstly take the most important one is radiational problems and solve with them with the technology. And lastly, I want to ask a few more questions actually for the audience. What really we want to provide for the humans there? And secondly, I want to ask, what else should we consider along after this whole presentation? I'm giving some second for you to think. And then you can write to the chat box or open your voice to talk. I can repeat the question as well. What we want to provide for humans in the outer space, and also what else should we consider along after this old presentation that I mentioned a lot for. Maybe I have some lack of information that you can just add. Is there something, or I just pass?
Okay, this one from Shivam. He says availability of oxygen.
Yeah, that's a great point.
And we have Aniket telling we need to protect humans from radiation, provide water, food, shelter, and oxygen.
Yeah.
We are again Shivam saying to make Mars magnetic field stronger.
Wow. Yeah. I wish we could.
We have Sebastian saying provide them with autonomy to care for themselves. We have Perif, I don't know if I'm pronouncing his name properly, saying also need to protect dust that comes from the Mars itself.
Yeah.
Yeah, we have Richira saying lightning conditions in that habitat on Mars. Okay, I think that's it.
Okay, great. And for tomorrow's presentation, I will mention about oxygen a little more. and the other rest, yeah. And so, how possible we can settle to the moon and then Mars. Today I will take part with the moon, and then tomorrow we'll continue with the Mars, and then some space architectural designs projects, and what kind of technologies they used, and etc. For the moon part, I will mention about Artemis project, Artemis mission, and with each of its technology, which is existed, and as some space architecture projects, they are not very yet constructed, so that if it's possible, really live on it on the Mars or Moon. But the projects I will talk about is existed and used as well. So these are existed technologies, not a story, really. So I want to start with the moon and continue with the Artemis and all the pieces of it. As you know, that there were a lot of missions to the moon initially. It started with the in the Cold War age with a kind of USA and Russian fight in the space industry. With the first mission of the Yuri Gagarin go to outer space, USA decided to land human to the moon. So between 1968 and 1972, the USA sent 9 Apollo missions to the moon. Each was carrying 3 astronauts, but all of them didn't success to land and take human to the moon. Among these 9, 6 of those missions landed on the moon, and finally 12 astronauts walked on the lunar surface. And all the missions are here: Apollo 8, 10, 11, 12, 13, 14, 15, 16, and 17. But Apollo 11, 12, 14, 15, 16, and 17 are successfully landed to the moon and carried human, and with these missions 12 people walked on the moon. And I will have some few questions again to you, and if my questions disturbing, I'm sorry, but I like making interactive presentations all the time. I pass for first questions. I think we have answered at the first presentations. Pass on the space exploration, why we do, but we can talk about why we are going back to the moon and how we are going back to the moon and what are new technologies and what are the differences between Apollo and Artemis. If you have some knowledge, you can just answer for the second and third question, why we are going back to the moon, and etc. I'm giving some seconds to you again. And also, if you have some answers, you can also contribute it from Frasat, if I spell wrong. I don't know.
Sure.
Yeah.
Okay, we again have Shivam. This work will bring new knowledge and opportunities and inspire the next generation.
Mm. That is kind of a similar answer for Moon and Mars, and both of them. But what is the difference actually, Moon to than the Mars? Why we are firstly decided to go to Moon, as the Artemis mission is the closest mission after Apollo mission, but why first the Moon and then Mars? I
Okay,
wonder
something
about the
more.
answer. Yeah.
Here's something more from Shivam. He
Yeah.
says the moon will provide a ground to test technologies and resources that will take humans to Mars and beyond, including building a sustainable, reusable architecture. Plus, the moon will provide. Okay, the same thing. Yeah.
Yeah, I got it. That's great answer, really great answer, and really that is like moon will be a kind of simulation. Actually, we do some simulation on the Earth, like in extreme environments, but the moon itself is extremer than the extreme points on the Earth. So that will be kind of simulation of the Mars, we can say. Even if the gravity of it is lower than the Mars, almost half of it, and the atmosphere completely different. No even atmosphere, and the condition of the meteor crashes and the other stuffs. But still, as it is the closest, we cannot say planet, but the closest land, outer space, the closest one to Earth that we can go and simulate there. So that's why Artemis mission took this advantage to test all the technologies they developed until now. So in that place, even they can get more knowledge, not only for testing technologies also, but also it can be a point for making better astrological researches. As you know that with the development of the technology and growth of the population of human, we are occupied all the corner of the earth. We cannot even find a clear place to make the best astrophotography and research of the uh, deep space because the lights will light it up the earth uh, in every point with the lamps and everything. So it makes this dirty sky and block the way of the investigation of the space. And also the earth has its thickness of the atmosphere and humidity and clouds that all the block of the way of making best astrophotography, astro research, and to learn deep space. So as the moon doesn't have that big block on on the way to look outer space, and there is the dark phase of it all the time. If we move to there with this consideration, we can use this advantage to make the research there as testing our technology and making human to adapt in this extreme land. If there is no other answer from others, I will pass on. Okay. Yeah.
Okay, there was one answer that Moon is comparatively nearer to the Mars while traveling. And,
Yeah. Yeah.
that's it, not the
Mm.
answer.
I was just it made me remind something, and yes, that's true. As the moon doesn't have the atmosphere like Earth, that is also not a block. It's not blocking way uh, for a launch um, to leave the surface.
Okay,
Maybe.
what I can say is Moon can be the best analog station for
Yeah.
going to Mars or any other planet.
Honestly, honestly. So, coming up to my question, as you know that from Earth to Moon, it takes like 3-4 days to journey. It is as the distance in the miles. It's very close when you compare it to the Mars, whereas it's 6-7 months to move, and you cannot come back in 2 years because, as you know, that when the Earth and the Mars returning around the moon, around the sun, it's just coming closer in 2 years. Each 2 years that come closer. So they decide in this period of time to make the launch from Earth to Mars, Mars to Earth. As the distance is long, also the second problem is about when they come to closer. That's why the humankind cannot just randomly and suddenly decide to send human to the Mars. It definitely they will die there, and they will maybe not be successful. So firstly, they need to simulate on the moon. As you said, that it will be the best, the largest analog area for the Mars, and the place of the testing technologies, and also you learn how to use new materials for construct on itself without a source of the Earth. This is the Global Exploration Roadmap from 14. It is 14 space agencies roadmap to the Mars. And as I mentioned earlier about Artemis, they are deciding to firstly make a lot of phases to the moon and then to the Artemis with the Artemis 2 to the Mars. And each Artemis 1 and 2 will have a lot of phases to adapt human to this mission. And it's very serious program, and decided with 14 space agencies together. However, I also want to talk about moon surface and Mars surface differences, and what kind of different problems they have from each other. It's also in this table, it's also written about some Earth orbits as well. I just want to shortly introduce a little about Moon and Mars surface. There are radiational differences, temperature and pressuring, and gravity, and much more. In these titles, I want to talk about first radiation, moon surface radiations, a difference than Mars surface. In the moon, it's exposure to solar particle events and galactic cosmic rays, low protection by the mass, but exposure to the secondary thermal. However, in the Mars, exposure to the solar particle events and the galactic cosmic rays, half protection by the mass and the atmosphere. As you see here, the Mars has a little more protection by its atmosphere. However, on the moon, there isn't. The temperature is kind of really different than each other. On the moon, mean -20 to the max to 123 degrees, and to the even -233. On the Mars, it's going to -63, but the extremely hot and extremely cold degrees are 20 and to -153. And also I can select from here the gravity differences. As you know that when we say the Earth is 1 g, the moon is almost divided to the 6, and Mars divided to the 3, according to the gravity to the Earth. So when comparing to the moon and to Mars and moon, it's kind of moon is a half low gravity than the Mars. Artemis, when coming up to the Artemis program, Artemis mission, it will be the closest mission to the outer space to land to a surface. And so Artemis phases are different than each other. So Artemis 1 will be for the moon and 2 will be for the Mars, but each of program will include of many different phases. So in 2024, it will be real missions to the moon, but however, it will not really start with landing human to surface in the first mission. In in this series of missions, Artemis 1, 2, 3, for the next year, at the Artemis 1 mission with no landing. As you can understand from this point, there will be a launch to the moon, but there will not be any landing. No human will step on the moon at the first phase. So after this one, the second phase will be delivering of the elements. So elements should go before a human to be prepared for human when they arrive to have their all needed elements to survive. And after landing all the sending and deliver all the elements to the moon, the first crew will step on the moon, and finally the first women will go to moon. Yeah. And this is the mission to the Mars phases, included different steps again. I hope that we can see these missions as done. It's planned for 2020, 30s, kind of that. It can extend it to 50s as well, but we are kind of trusting to the Elon Musk word that is 30s, I hope. So what are the technologies used in the Artemis program? And there are different components we can mention about SLS. This is Space Launch System, and Orion Crew Vehicle and Gateway. Included different parts is PPE and Halo. And finally, HLS, Human Landing System, will be talked on this presentation. This is completely SLS Space Launch System. You can see all the details with the model, how it's connected to each other, and where is the point that human will take its place. As you know that after SpaceX missions to the space, they improved the best way of making the space industry in the more economical way, as using sustainability. Sustainability is very beneficial in the economical save, as using all the components reusable. So all the launch part also can be used for the second missions at Artemis program as well. And for the Orion part that will carry astronauts to the moon has different differences between initial Apollo capsule when we compare to the Orion. The distance, it's the largest than the previous designs, and has better technologies inside, and it gave the opportunity to the astronauts to have largest area to use, and also the points with the space architects, they made more fancy and beautiful inside design that will definitely affect human psychology, I believe. The Orion spacecraft, we can divide two different pieces, as you can see in the picture. The crew module will space in the middle of the launch abort system to protect until it reached to the destination. And it has also spacecraft adapter and service module in this bottom part to the right. And also want to talk about the gateway. This is the amazing technology which is not used in the Apollo missions or previous missions. This also shows the importance of sustainability, as it is multi-use gateway that is moving, that will be first kind of ISS system returning around the moon. We have a lot of ISS and Skylabs turning around to Earth, but that will be kind of initial one that will return around the moon for next missions as well. So this will help human to multi-use it, and they will never need any second technology or component for coming back. It's returning around the moon that helps mission to decide where they want to land. As it is returning, they can decide when to cut off from this gateway and to land to the surface, and it will be calculated to catch the time when it's coming to the same direction of the humans, so they can connect to this gateway to come back to the Earth. It has two different parts. Its PPE is power and propulsion elements, and also the second one is Hello, its habitation and logistic outputs. So this is completely connected to the human landing system, which is placed here. So human landing system will help astronauts to come to the surface and go back whenever they need. So my last question will be about what will we do after landing to the moon surface. I'm giving some seconds for you to think about it. You can text or open your voice to talk. Yeah.
Research is the first answer we got from Aniket.
Research. Yeah.
We have set up a moon station.
Yeah. Set up a moon station, moon base.
Again, we'll build a permanent station on moon.
Yeah.
Growing plants we have. We are extracting water from the moon soil like frozen
Wow.
water.
Very important point, honestly.
Yeah. And we have, okay, the same one like a Trident project.
Yeah.
We have print habitats out of dust.
Yeah. From the regolith itself. That will teach us how to use the resources of the land as well. Okay, is that all?
Yeah, that's all for now.
Okay,
Still need a
so
comment.
break. So I'm finishing first part here. We are going to continue tomorrow at same hour. I'm almost presenting 1 hour, so we'll give time, maybe 30-40 minutes, maybe. I don't know how much you need for the Q&A part. So tomorrow will be same. I will continue with the Mars technologies, and then after learning those all informations, how we can combine all the information to the architectural designs in space. We will talk about a lot of diverse topics in space. Yeah, thank you so much for hosting me. That's all my presentation.
Thank you, Elif. That was a great presentation. And for the participants, if you have any other question, you can just put it in the chat box.
I ask my all questions, so time for you to ask me questions. Until then.
Okay, we are waiting for the questions. Okay, here's the first one. Do you believe it would be possible to build a station by 2025?
To be honest, I don't believe. If you want to know if I believe or not, we are imagining, but We love to postpone, as I did to this team as well. That will be planned for this year, but it's very nice to design to plan for the next near future that will accelerate our performance. Um, but even if we cannot make it on time, as Elon Musk said, uh, like I don't remember who sentence of him, but he meant that um, I plan something even if it doesn't happen on time, but it will happen one day. So even if not on time, but will happen one day. I believe that point that will happen one day. Yeah.
Okay,
Can I have
yes,
questions if they don't have questions?
yes, another question.
Yeah.
What is the greatest challenge of space architecture, and do you think recalled phase will be durable?
Yes. Great challenge in space architecture. Actually, the great challenge is about it is extremely different than the Earth. Our body, our psychology, and learning, and everything is based according to the Earth. So even the programs we use is according to the Earth. Like we design, we model, we render, everything is set according to the Earth. But when we decided to do it for space, we have very extreme new ideas, and we don't have enough technology actually to use an architecture like new, how to penetrate the different gravity of this new area, how to design in the outer space, how computer programs can help us in this way. And also, it is not only for designing, we have to learn and research all the time, and you have to be the best researcher, and don't never consider yourself only as architect and designer, also like a psychologist, and also you have to be multidisciplinary person. That is the challenge. And coming up to the second question, it is about the regolith basis, how it will be durable. As I know that from the history of the architecture, what happened in the old history on the earth, even that didn't work well on the earth. I mean, the mud or the plasters that found on the first time, um, as you know that in the stone age, from the cave to the houses, making the houses of this time, we pass a lot of steps with a lot of tries, but the first one were not the perfect, so it will perhaps follow the same step of the experiences what happened in the old history of the architecture on the earth. Yeah.
That was a great answer. Next we have is, what is the most important tip about carrying architectural structures from Moon and Mars? What are the critical points?
Hmm. Critical points. Do you mean about carrying components or technologies on the Earth to the Moon, Mars, or
Yeah, I think it's the
didn't
same.
get? Okay. Uh, yeah. For that one, actually, the critic points. There are critic points, but for making these critic points as the least one, we have to make the a lot of simulation and in the extreme environment. There is also one title in architecture that named extreme environmental architecture. Even there are annual competitions on that. They only work on the extreme environments to test. We have to do this to diminish the critics, the problems. So also Artemis decision to first go to the moon and then the Mars is coming from this idea to decrease the critical um, problems in case of if we go to the further.
Okay. Next, we have question that I'll need to modify. Kaushik is asking with the similarities between the atmosphere of Moon and Mars.
Hmm, similarities. Oh, there is no similarity. It's very different than each other. It's not neither similar to Earth, neither too similar to each other. Like Moon includes more carbon dioxide, and as Earth has nitrogen more, like we don't only need oxygen. Oxygen takes a smaller portion of having breathable air. For the Moon, there is no atmosphere, like kind of. That's why it has a high damage of the meteoric crashes. Yes.
Next, we have a question from Triloki. He says, "What is the confusion regarding Elst Pizarro? Why they have a tail like a comet, and why we count him a asteroid or comet?"
Mm, to be honest, I'm not clear. I'm not sure about this question. How to answer? I'm not sure. So can we pass on?
Yeah, I also think it's a
Sorry
bit
for
of like
you.
space
Sorry for
architecture.
you.
Okay, we have Amuel. He's asking, do you think 3D technology used on Mars too?
Yes, it is planned to use on the Mars too. So for the Artemis second, they have, as I said, are have different phases again. So like they will deliver needed technologies firstly before of human going there. So this technology will include of 3D technologies, 3D printing technologies. So it will definitely used if they successfully move there. So tomorrow we will talk about more about Mars, and then the projects will done on Mars. You will see on these projects 3D printing technologies mainly used in those projects because human power will not work. So technology with the machines will do a habitable area with this technology actually. Yeah.
Next, we have a question from Ruchira. She asks, why all habitats are mostly dome or spherical shaped?
Yes, because of it is durable for the pressure. Pressured is the safest shape actually. It has high durability. That's the answer.
Okay, we have a question from Milky Way itself. What should be minimum and maximum height of building built on a moon?
Hmm. Yes, that's a great question. So better not having any height because we are planning to go under the ground for the moon and then Mars even. So because there is no way to protect from the radiation. Radiation is too high and it's killing human like so initial projects perhaps will be underground. So making high will make a lot of damage and hazard from the meteoric crashes. So as much as you could, you be closer to the earth, to the surface will be the best project concept if you want to design your competition project.
Bharat wants to know the progress of Artemis program.
Can you say again?
Bharat wants to know what is the progress of the Artemis program.
Mm. They intended to do first launch actually in 2021, but they like and in the end of the 2021. But as I said, that they we always plan and then postpone. So it is like in this year they are planning to do for that for the like no human carrying, just I mean no land for the Earth, but making test of the how to go to moon in the transportation way. About if talking about the technology which are produced, the SLS and the gateway, these are in progressing.
Rajpal Singh wants to ask, would it not be against the law of the nature to send humans to on other planets?
Hmm. Hmm. Difficult question. But as you know that they are deciding by themselves to go there, and they are educated, they are stimulated in a lot of way. They are in health. They are completely different than us, like doing a lot of sport and trades, and it takes long years for them to do that. And they are perhaps signing us something that we are taking our responsibility. And for the Mars itself, I actually also think about this question. It will be out of the law actually to send the human to the Mars because they perhaps will die. Who is accepting this is very weird. Maybe that person is not very hope on the moon, on the Earth. Um, it's not actually clear. It's not actually a very simple question to. Maybe we can ask to astronauts if they really accept to do that. Yeah.
Okay. So we have Ruchira again. She wants to ask, how will structure designed using origami help us in the space architecture?
Um, yes, I have came across a lot of kind of projects that come from the origami, and it's really amazing shape that give you uh, small area that can extend suddenly with large area that I mentioned whole of the presentation about the sustainability to make multi-use and to make areas that can be smaller and the biggest and flexible way to multi-use and reusable. These are all included actually in the origami shaped and really if you have this talent to uh, reverse origami concept to the building, really go on that and it will help you. And for secondly, I can give you advice of the using biomimicry. Biomimicry is one of the most important in the design to take the samples from the earth itself to the from the nature itself. So maybe you can combine these two or consider on both. Yeah.
Okay, if we have Sebastian again asking, any thoughts on underground architecture for the moon especially?
Yeah, there are. There are like two different concepts. One of them to completely go underground, or to collect regolith on the building itself. And I forgot the project name, but it's made by Mars Explorer. Mars. I forgot team name. So actually, there are projects that consider it for making architecture underground. Like it is also biomimicry taken from the ants itself. So how the ants instructed their houses underground, how they make ventilation, from which points would they do opening for making ventilation inside. But however, they are living on the earth, they can do it, but with the living on the moon or Mars, we cannot do natural ventilation, but we can make it interior air movement to make it a clear livable area.
Okay, I
Okay.
have a question continuing to this. That uh, how will sun help in on moon if we consider how will be sun helping us in just growing the plants? Means out on moon we definitely will be growing the plants inside the building or whatever we build there. So how will sun play the role exactly in that?
Mm. You mean that if we are planning to plant, like grow plants, how the sun will help us in this?
Okay,
Yeah,
yeah, in
yeah,
the indoor environment.
yeah, yeah. Actually, as you know, that if we talk about I will always give you answer with two titles, with the moon and Mars, okay? Because these are completely different. Yeah, for the moon, as you know, that the atmospheric problem, so the sun is directly coming and not very beneficial for the planets to grow actually. And on the Mars as well, it's kind of same, but the lights uh, lights usually sometimes damage if it's direct. So they use the horizontal lights for plants, and mostly there is artificial lights that is beneficial for the planets to be to grow. But still, the sun it's naturally has plants, but not direct one, of course. That should be uh, like transparent, halfly translucent windows to take enough one to inside. As using this transparent or translucent facades of windows or material with the concept of atmosphere of the earth. You understand? Yeah.
Uh, Another question I have is regarding the stability of the buildings we build there. Means if we ever plan to build a building on the surface of Moon or Mars, what will be the depending on for stability?
Stability. As one of the friend asked about why domes. Yeah, this is the answer actually. So why domes? Because domes is helping for the stability, and some other ways of how to connect with the dome or dome shaped one. And for the stability also, we can take the samples from the biomimicries, how actually in the nature they are uh, stable. And with this case, uh, I believe that if they are taking from technology from the Earth itself, for Moon it's possible as it's close, but Mars will be very extremely different. So the technologies which are used on the Earth will help for uh, the structural support. That is what I can say.
Will that give the answer?
Yeah, yeah.
Okay. So the participants will be waiting for 2 more minutes if there is any question, or else we
I
can.
would ask a question actually if they still have time.
Yeah,
I
yeah.
want if the students are very new in this title, if they are progressed something, if they're new, why they're interested in, and if they're not new, what they do, what they. I want to people just open camera and talk. Actually, yeah,
Okay, I
about
think I'll have
their
to give a mic.
experiences.
I'll give them the permission to turn on their mics too. Anyone who is interested to come up and speak on this can raise your hands. Okay, we have Ali joined room. Yeah, you can just unmute yourself and start.
Yeah, hello. I'm new to this actually. I'm just an English teacher that teaches a group of aerospatial students, and we're
Oh,
studying space architecture this semester. And I was just curious about what the latest research was. It was a very interesting talk. Hearing you speak about it, very insightful.
yeah, great. Welcome.
Thank you.
We are waiting for you tomorrow as well.
Will do.
Okay.
Okay, next we have Triloki joining us. Yeah, Triloki, you can go on.
Hello, ma'am. Hello, sir. Actually, I want to ask, is there any mission of asteroid research like Psyche spacecraft of NASA or Catastilia mission of S. Pizarro, like any mission from India for asteroid research? Like I
India.
have involved in asteroid research with NASA at international level. Uh, I also want research for that, like another research related to asteroid, like a comet or
Hmm.
something else. So can you guide me?
Yeah, if you want me to contribute, like give you information about that, really, I'm not in that title. I'm mostly researching about space architecture, Moon and Mars. So asteroid is too far to me. Can you learn and share with us tomorrow? Sorry.
Okay, ma'am.
So I just saw a last question at the chat box. It says Sanika ask something. Uh, you can read for us, At maybe. You see? Do you mute it?
Yeah,
Mute
I'm
it?
sorry. Yeah. So the Sanika asks whether the journey from Earth to Mars takes months. So what efforts are being put to reduce this journey time, like changes in the structure of spacecrafts or propulsion system?
Hmm. That is really amazing question. First time came across this question. Very nice question. That should be considered actually to make this journey shorted. So if it gets shorted, that they will get more time on the Mars to span and develop. So with this thing, I believe that the growing technology will help this to be faster to move and reduce the time of journey, as the reducing time of journey will help human not to spend like 6 7 months at the small capsule, as if the hardest land is waiting for them. I hope the space architects and space engineers will help them for the safest living area. So if we success on this technology, reducing with the time of journey will help all the process. That can be, as I said, firstly, growing technology and a rocket, how a rocket can move fast, or all the launches can move fast, and also as we just mentioned it about when we talked about the moon can be used a place for a launch that kind of maybe 4 days closer will not help a lot, but still as actually for the launch oxygen is needed, but they still need to find a solution of that as well. That can be a second solution maybe. So maybe like I also considered suddenly about if the power of the moon can be used like to move further fastly. Yeah.
We have Bharat raised his hand. Bharat, you can share what you want to share.
Hi, Elif. Hope I'm audible.
Yeah, you're audible.
Yeah. So I have been doing my research for space architecture. In fact, I've gone through the course provided from AIAA, and this is from Barbara. And
Mm.
I also know that intensive research, for example, there is a sample module of She. I've been asking, I'm going to ask you the same question when I asked them. Humans are most tuned to the circadian rhythm on Earth, and all our life really depends on it. We are tuned to waking up when the sunlight comes up and then rest when the sun goes down. So that really doesn't happen in the either in the International Space Station nor you're going to have interplanetary travel. So how much of a lighting research or intervention is being carried over in spacecraft or on landers
Mm.
for human comfort?
Yeah, can you just repeat the question part again?
Yeah. So the circadian rhythm is something that is going to affect human performance even during performing missions.
You say
If
psychology, right? I don't clearly hear.
circadian rhythm, the
Yeah.
so that's the circadian rhythm is our what exposure to sunlight and our activity based on that. So in while we are on spacecraft and International Space Station, for example, the International Space Station I believe has 18 sunrises and sunsets.
Mm,
So
yes,
if you
that's
really
true.
can't perform, really can't perform in such environments, and astronauts get sleep deprived. So when you're on a shuttle, when you really don't have even an opening in the capsule, how is that circadian rhythm is going to influence the? Or is that a research? Is that a consideration for lighting design? I'm an architect myself, and I'm a lighting designer as well. That's why the question.
Yeah, that's a great question. For this part, actually, for the ISS astronauts at ISS, it's strongly controlled, but by the ground control. So they, because really, they postpone about everything, not only sleeping hours, as they are not at the first week. It's getting harder to be adapted to these differences. Like in 90 minutes, they getting morning and night very fast, and they getting difficulty to adapt in the first week. So after that, it's going to little growing adaptation. But even after that, it's always controlled by the ground control, as even they are not only skipping sleeping hours, but also they are skipping eating hours, even eating habits of them. Coming up to the Mars, actually Mars very similar to the Earth about the day and night. There are some hours differences, so this not very considered for the Mars about adaptation of the day. But that is the serious problem for the ISS. It's controlled by the ground control. For the mission, like the journey from the Earth to the Moon takes long days, and with the small capsule, as long as it goes with the ground control, that will always taking support from it, I believe. Yeah. I hope that answered your question.
Yeah, thank you, Elif.
You're welcome.
Okay,
Yeah,
so
we have
as
finished
I,
questions.
yeah, I don't see anything more coming up. So
Yeah.
I just want everyone in the meeting to just turn on their cameras for a screenshot.
Yeah.
Please, everyone. Okay, we have some more. Aditya, Sanika, say that Aditya, Richa. If you all guys can, please.
Nice to see you all.
So are you guys ready? Should I take the screenshot?
Some voice.
I think that's it. Okay.
Thank you.
Thank you so much. Nice to see you all, and hope to see you tomorrow too. At the
Okay,
same hour. Yeah.
thank you guys for joining, and we'll be sharing the link for certificate and feedback tomorrow itself. So I hope to see you all guys again tomorrow.
Welcome. Thank you. Thank
Thank
you,
you.
everyone.